high. This is an RPM low pressure indicator. So this indicates the percentage of the velocity of the low pressure turbine. So this was manufactured by Intercontinental Dynamics Corporation. You can see the hidden plate. The power supply is 26 volts AC. So it should be used with a tachometer generator. The input is a variable frequency input. So the input of this thing is the frequency. We have both digital and analog indications. And I have two of them. I got one for free. On the left side there is an adjustment for the brightness of the display. I'm looking for a date. Yes, so this was manufactured in 1984. So let's open this thing to see what is inside. Okay, so we have 3 PCBs. So in the middle, this looks like a power supply board. You have several filtering capacitors, a transformer here, some regulators probably, or transistors and op-amps. On this side, we have this part. The reference is obscure for me. Date code 84. So we have another obscure part here. TSC 840 ICL. And here we have 74C 902 logic ICs, but it's not common for me. And here we have a CD 4070. On this side we have 2 EEPROMs. That's right, so this is common, CD 4511, so this is a driver for the 7 segments display. So we have 4 of them because we have effectively 4 displays here. So we find also 2 DAC here, the classic one, DAC 0800. So we can try to supply this thing. The power supply is 26 volts AC. It can be also possible to apply an AC voltage at one of the secondaries of this transformer. This is maybe the best solution. So I'm going to remove the top board here. Okay, so we have several flat cables here. This is a little bit annoying, but you can see the power supply board. So we have effectively 3 regulators. I am going to apply an AC voltage at the input of this diode rectifier here. There are 4 diodes. So we start with a low voltage. Okay. It seems that we have a problem with the display. We will see. Now I will try to find 26 volts AC on the rear connector or something close to that voltage. Okay, so here I have 26 volts. We check with the ohmmeter. Okay, the resistance is 3 ohms. Okay, so the voltage is 26 volts now. It seems we have some problems with the display. So this is maybe the problem of the display itself. or a problem with one or several drivers. What we can do is to permute some drivers here. So it seems that there is a problem with the driver in the middle, but I am not sure. At least with this one. One segment is missing. So let's permute, for example, these two 4111 here. So I see they are socketed, but the socket can be also a problem. It is not common to find sockets in avionics. Okay, this is the same. Two segments don't work, so probably there is a problem with the display itself. Okay, so it was the display effectively. Let's see if these wires are connected to the rear connector. This one okay. This one also. One of these wires are probably the input. You can see that this orange wire here is connected to this track. There is a resistor of 200 kilo ohms here. And the second input is connected to this resistor, which is also a 200 kilo ohms resistor. So let's try to apply a signal to this terminal. I need to find the ground also. I'll check the capacitors of the power supply. Maybe, yeah, they are connected together here. And there is a conformal coating. So this is obviously the ground. It is not connected, this is strange. Okay, it is connected to the power supply input. The power supply is not isolated. Okay, I have connected two wires to this signal here. So I will connect one to a function generator. Okay, we have something. So I have connected this one. I don't know. There is a frequency of 400 Hz. So I will reduce the frequency. Okay, so maybe the frequency was too high. 1 Hz. 10 Hz. 20. 40. 50 and 60 Hertz. 100% is achieved for a frequency of exactly 56 Hertz. So we decrease a factor of 2, 28 Hertz. Okay, 50%. So this thing works, except I will permute the display of the middle, and this one on the left, it is never used except for values above 100%. I have exchanged this display with this one here. It is better. One segment is missing. Yes, several segments are missing actually. I have another one. We can test the other one. This is the other one. As you can see, it is absolutely identical, except the front color. Okay, so let's have a look. This one seems better. Okay, perfect. So I don't know the use of the second input. For the moment I have connected the input signal to one of them. I don't know which one. You have to check. It seems identical. So it seems that there are two inputs which have more or less the same function. We can see also that we have two power op amps here. So we have two DACs, as we have seen, and two EEPROMs here. And if we follow the wires, which should be the output of the op amp here, obviously, so there are the red wire and the blue wires. These wires are connected to this resolver here in order to drive the needle. So it seems that all these circuits are used to drive the needle. So there is maybe a sine and a cosine generation. This circuit generates two signals, one for the x-axis and another one for the y-axis, in order to drive the needle in all positions. Because I don't know exactly what is this thing. It looks like a synchro. Okay, I will connect this thing to a power supply. I will connect one wire, this one, for example, to one power supply. This thing is a common line of the power supply. I am using this AMEC power supply with a dual output. So the common of these two power supplies are connected to the common point of the DC synchro here. I need another one. Okay, the other one will be negative, for example. Okay, so the first, the voltage on the first one, so effectively so this is 0. I will increase the voltage on the red wire in the positive direction, and I will increase the other one in another direction. It is possible to set the position of the needle anywhere on the scale, depending on the DC levels which are applied on these two coils of the DC synchro. The main measurement is a digital output, so this measurement is fed directly to these decoders in order to drive the 7 segments display. Otherwise, there is a translation between this digital value into two DC currents, one with sine, one with a cosine value, and this drives this synchro. So this middle board is a power supply, and this one is a board which permits the measurement. So the input is here. Everything is socketed on this device. So this is the classic 2222. And here we have our pumps, OP14. And this is the LH something, 0070. And this part is also obscure, TSC 940 ICL. This was the teardown and the test of this RPM percentage low pressure turbine indicator. Thanks for watching and see you next time. Bye.